Hey everybody, it's Mr. Carr again. Today we're going to be talking about 7.5, properties of logarithms. So when we talk about our properties of logarithms, we're talking about three of them here. Okay, there's a product property, the quotient property, and the power property. Okay, so product property. Again, key here is that bases are all the same. Log base b of a plus log base b of c is the same as taking log base b of a times c. So what we're saying here is that these two arguments get multiplied together as long as this is addition. The quotient property, same thing, it's got to be the same base number here. So if we are subtracting the two logs, we can put them together as a division problem. That's a quotient idea. Okay, so again, addition turns into multiplication, subtraction turns into division. The other part of this is if I am multiplying log base b by some number, that is the same as taking that c as an exponent for my argument. Okay, so you'll see how these work on some of these other problems, but a very basic example would be like if I take 2 times the log, we'll say base 3 of 9. Okay, that's the same as taking log base 3 of 9 to the second power. That's all it is. So we just take this right here and move it over there. Okay. So let's use that on the next few problems. We're going to use them as part of our solving process. So first example, using our product property. Log base 6, log base 6. Okay, so log base 6 of x plus log base 6 of x plus 5 is equal to 2. So the idea is that we can use our product property to, it's called condensing it. We put two different logarithms together as one logarithm that is going to be condensed. Okay, so once I do that, remember this is addition, so it's turned into a multiplication. Log base 6 of x times x plus 5. Okay, and that is equal to 2. So officially, this is just one logarithm. So now, remember solving it from before, we're going to turn this base into this with this exponent. So x times x plus 5 is equal to 6 to the second power. Well, that is going to turn into quadratic. Okay, so same thing that we did before with quadratics. So if I distribute that out, so x squared plus 5x equals 36. Subtract that to the other side, so x squared plus 5x minus 36 equals 0. So we need to solve this quadratic. So I can do this with factoring here because what multiplies to negative 36 adds to a positive 5. That should be a positive 9 and a negative 4. Okay, so that means that if I solve them out, x plus 9 equals 0, x minus 4 equals 0. So x equals a negative 9 and x equals 4. However, since we're dealing with logarithms, we need to double check. Do these actually work in the original problem? And negative 9 will not, because if I plug in negative 9 here, log base 6 of negative 9 does not work. Okay, so that actually makes this extraneous. Again, we solved for extraneous, we solved it, came out to a real answer with x equals negative 9, but it does not work in the original logarithmic equation. X equals 4 does work because I can take log base 6 of 4 and I could take log base 6 of 4 plus 5. These are both okay to evaluate because they will be positive numbers here and here. Okay, but the negative 9 does not work here. It actually doesn't work here either, but all I care about is it fails the first one, so I don't need to check the second one. All right, so that's our product property. Quotient, whoa, hello. Okay, quotient property, same idea. Okay, log base 3 equals log base 3 of 5. So in this case, we are going to condense it, but then we're going to have the same logarithms on both sides. So watch what the condensing looks like. So these are going to be division problems. So log base 3 of x plus 3 over 4x minus 1 equals log base 3 of 5. Okay, and again, since we have this log base 3 is the same logs, we can actually just drop them, get rid of both of those, and make it x plus 3 over 4x minus 1 equals 5. I'm going to make it 5 over 1 because now this is set up through solving through proportions. So we're going to do my cross multiplication here. So 5 times that, 1 times that. So 1 times x plus 3 leaves it as x plus 3. 5 times 4x minus 1. So that gets distributed. So x plus 3 is equal to 20x minus 5. Subtract the x over and we'll add 5 to the other side. So 3 plus 5 is going to give me 8. 20x minus x is 19x. And then my last step is to divide that out. So I get for my final answer 8 over 19. Okay. Again, just do a quick double check. If I plug it in here, that's a positive value. That's good. If I plug it in here, 4 times 8 over 19, and then minus 1. Let me just make sure it should be fine. 4 times 8 over 19 equals that, minus 1. Yep, it is still, it's a decimal number. It's a small, or it's a fraction, I should say, but it's okay. All right. So quotient rule, lots of times you'll see cross multiplication you'll have to solve. Last thing is using our power property. So use the power property on the left side of the equation and the product property here on the right side, and then we'll solve it from there. So log base 7, again, they're all the same bases. So on the left side, my power property says to put the 2 there as an exponent. So log base 7, make that a little better, log base 7 of x squared equals the condensing of log base 7, can't throw 7s today, of 27 times 3. Okay, so that's again, the condensing of the addition turns into multiplication. So now, with the same logs on both sides, I can just drop them. X squared is equal to 27 times 3. So 27 times 3 is going to give me 81. And now to solve that out, I square root both sides. Now, because of the way it's set up, I would do plus or minus 9 here. Okay, because technically speaking, I would do that. However, look at the original problem. 2 times log base 7 of x. So the negative answer won't work. So the negative 9 is actually extraneous. So my only answer here is x equals positive 9. Okay. And that is it for 7.5. Again, the goal here is we're still going to be solving with our logarithms like we did in the last unit or our last lesson. Okay. But we have to apply either power property, quotient property, or the product property to help us get there to something that's solvable. Okay. And that's it for today. Take care, everybody.